In this video, I'll work through an integrated problem that involves both kinematics and applying forces, and I'll work through a sample problem calculating relative velocity. So in our first scenario, we've got a 1-ton car accelerating from rest at 3.2 meters per second squared for 15 seconds. We're asked to calculate the net external force, the final speed in kilometers per hour, and the distance covered. So let's list the things that we know. We're given acceleration, we are given time, and we are given mass is 1 ton, which I'm straight away going to convert into kilograms. We're asked first of all to calculate the net external force, and the formula for that is mass times acceleration. So the first part of the problem is actually quite simple. It's just applying Newton's second law. So the net external force is 3,200 newtons. Next, we're asked to calculate the final speed in kilometers per hour. So I'm going to first calculate in meters per second, and then I'll convert that answer into kilometers per hour. So I can have a quick look at my list up the top here of formulas. I'm going to want to use this one to calculate my final speed. I already know, I was told that the car started at rest. So that tells me that this is 0, so velocity is going to be acceleration times time. So 3.2 for 15 seconds is going to be 48 meters per second. And I want to express that in kilometers per hour, so I'm going to do a super quick unit conversion. Meters on top, so it must be on the bottom. Seconds on the bottom, so it must be on the top. Gives me 173 kilometers per hour, so a super fast car. And lucky last, the distance covered. And I can see here that I can use this formula. Again, initial velocity is 0 because the car's accelerating from rest, so that's just going to be half acceleration times time squared. Which is equal to 360 meters. Cool. Okay, and our second problem. 2 cars driving perpendicular to one another are approaching an intersection. Car A is driving at 70 kilometers an hour due east, and car B is driving at 100 kilometers an hour. And we're asked to find the velocity of car B relative to car A. So I'll draw a diagram. If car A is here, car B must be here, and we know that this is east. We're told the velocity of car A is 70 kilometers an hour, and that car B is 100 kilometers an hour. So we're being asked, if we're looking this way, we're looking in this direction, we're in the place of car A, then we want to know how fast, or what is the velocity of car B based on where car A is situated. So if car A was stationary, how fast would it appear that car B is going? So really, we just have a right triangle problem again. So we want to find the length of the hypotenuse to determine the magnitude of the velocity. So that's using Pythagoras' theorem. And that's going to be 122 kilometers per hour. And I want to know the direction. So again, if we're looking in this direction and this is due east, then the angle that I'm looking for is going to be this angle here, which is the same as this angle. So relative to this angle, this side is adjacent, this side is opposite. I'm going to use the tan, opposite over adjacent. So the angle is the inverse tan, which is going to be 35 degrees. So my final answer, the velocity of car B is going to be 122 kilometers per hour, traveling east 35 degrees south.